The National Electrical Code, or NEC, does not explicitly require the use of conduit in all electrical installations. However, the NEC provides extensive guidance on when conduit or other raceways are necessary to ensure safety and compliance. The requirement for conduit often depends on the specific application, environmental conditions, and the type of wiring being used. It is crucial to understand the relevant articles and sections within the NEC to determine the appropriate wiring method for a given installation. Article 300.15 of the NEC addresses raceways and cable assemblies entering boxes, conduit bodies, or fittings. This article necessitates that where raceways are subject to physical damage, they must be installed in a manner that protects the conductors from such damage. This often implies the use of conduit, especially in environments where the wiring is exposed to mechanical stress, impact, or abrasion. The specific type of conduit required, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or flexible metal conduit, will depend on the severity of the potential physical damage and other environmental factors. Article 300.4 of the NEC focuses on protection against physical damage. This article covers various aspects of wiring installations, including the protection of cables and raceways from nails, screws, or other objects that could penetrate them. It also addresses the need to maintain the structural integrity of buildings when installing electrical systems. Specifically, Article 300.4 emphasizes that raceways and cables must be installed in a neat and workmanlike manner, ensuring that the installation does not compromise the structural integrity of the building. This requirement implicitly suggests the use of conduit in situations where other wiring methods may not provide adequate protection or may pose a risk to the building's structure. In corrosive environments, the NEC often necessitates the use of conduit materials that are resistant to corrosion. This is to prevent the degradation of the wiring system, which could lead to electrical hazards. For example, in areas where chemicals or moisture are present, rigid non-metallic conduit or coated metal conduit may be required. The NEC provides specific guidelines on the types of materials that are suitable for different corrosive environments. Article 347 covers rigid non-metallic conduit, outlining its approved uses and installation requirements. Article 344 addresses rigid metal conduit, specifying the materials and installation practices that ensure its durability and safety. In wet locations, the NEC requires the use of wiring methods that are approved for wet environments. This often includes the use of waterproof conduit and fittings to prevent water from entering the wiring system. The NEC defines wet locations as areas subject to saturation with water or other liquids, such as outdoor installations, car washes, and some industrial facilities. Article 314.15 discusses the protection of boxes and fittings in damp or wet locations, emphasizing the need for weatherproof enclosures and fittings to prevent moisture ingress. Article 350 covers liquid-type flexible metal conduit, which is often used in wet locations due to its flexibility and ability to prevent water from entering the conduit system. When raceways are exposed to traffic, such as in parking lots or loading docks, the NEC requires the use of conduit or other protective measures to prevent damage from vehicles or equipment. This may involve burying the conduit underground or installing it in a protective barrier. The depth at which conduit must be buried depends on the type of conduit and the type of traffic it is exposed to. The NEC provides specific guidelines on burial depths in Article 300.5, which addresses underground installations. In some cases, the NEC may allow the use of cable trays as an alternative to conduit. Cable trays are open support systems that can be used to support cables in industrial and commercial applications. However, the NEC specifies that cable trays must be installed in accordance with Article 392, which outlines the requirements for their construction, installation, and use. Article 392 also specifies the types of cables that are permitted to be installed in cable trays and the conditions under which they can be used. The NEC provides guidance on the sizing of conduit to ensure that it can accommodate the conductors being installed. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit, based on the type of conductors and the size of the conduit. Chapter 9 of the NEC contains tables and examples that can be used to determine the appropriate conduit size for a given installation. These tables take into account the full percentage of the conduit, which is the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC also addresses the grounding and bonding of conduit systems to ensure electrical safety. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Article 250 of the NEC covers grounding and bonding requirements, including the methods for grounding metal conduit and other metal enclosures. It is important to note that the NEC is not a design manual, and it does not provide specific instructions on how to design an electrical system. Rather, the NEC sets forth the minimum requirements for electrical safety, and it is the responsibility of the electrical designer to ensure that the electrical system meets these requirements. The NEC is updated every 3 years, and it is important to stay current with the latest edition to ensure compliance. The NEC is published by the National Fire Protection Association, or NFPA, and it is available for purchase from the NFPA website. In addition to the NEC, many local jurisdictions have their own electrical codes that may be more stringent than the NEC. It is important to check with the local authorities to determine the applicable electrical codes for a given project. The NEC provides detailed information on the types of conduit that are permitted for use in different applications. These include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid non-metallic conduit. Each type of conduit has its own advantages and disadvantages, and the choice of conduit will depend on the specific requirements of the installation. Rigid metal conduit, or RMC, is a heavy-walled conduit that is typically made of steel or aluminum. RMC is the most durable type of conduit and is often used in applications where it is subject to severe physical damage. Intermediate metal conduit, or IMC, is a thinner-walled version of RMC that is also typically made of steel. IMC is lighter and less expensive than RMC, but it is not as durable. Electrical metallic tubing, or IMT, is a thin-walled conduit that is typically made of steel or aluminum. EMT is the lightest and least expensive type of metal conduit, and it is often used in applications where it is not subject to severe physical damage. Flexible metal conduit, or FMC, is a flexible conduit that is typically made of steel or aluminum. FMC is used in applications where flexibility is required, such as connecting equipment that is subject to vibration or movement. Rigid non-metallic conduit, or RNC, is a conduit that is made of plastic. RNC is lightweight, corrosion-resistant, and non-conductive, and it is often used in underground applications or in corrosive environments. The NEC provides specific requirements for the installation of each type of conduit. These requirements cover topics such as support spacing, bending radii, and the use of fittings. It is important to follow these requirements to ensure that the conduit system is installed safely and correctly. The NEC also addresses the use of boxes and fittings in conduit systems. Boxes and fittings are used to connect conduit runs to provide access to conductors and to protect conductors from damage. The NEC specifies the types of boxes and fittings that are permitted for use in different applications, and it provides requirements for their installation. The NEC provides guidance on the proper methods for supporting conduit runs. Conduit must be supported in a manner that prevents it from sagging or moving, which could damage the conductors inside. The NEC specifies the maximum spacing between supports for different types of conduit, and it provides guidelines on the types of supports that can be used. The NEC also addresses the grounding and bonding of metal boxes and fittings. Metal boxes and fittings must be grounded and bonded to ensure that they are at the same electrical potential as the grounding system. This helps to prevent electrical shock hazards and ensures the proper operation of electrical equipment. The NEC provides detailed information on the methods for grounding and bonding metal boxes and fittings. The NEC addresses the use of conduit in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. The NEC specifies the types of conduit that are permitted for use in hazardous locations, and it provides requirements for their installation. These requirements are designed to prevent the ignition of flammable materials by electrical sparks or heat. The NEC also addresses the use of conduit in healthcare facilities. Healthcare facilities have unique electrical requirements due to the presence of sensitive medical equipment and the need to protect patients from electrical shock hazard. The NEC specifies the types of conduit that are permitted for use in healthcare facilities, and it provides requirements for their installation. These requirements are designed to minimize the risk of electrical hazards in these critical environments. The NEC provides guidance and the proper methods for terminating conductors in conduit systems. Conductors must be terminated in a manner that provides a secure electrical connection and prevents them from coming into contact with the conduit or other metal parts of the system. The NEC specifies the types of connectors that are permitted for use with different types of conductors and conduit, and it provides requirements for their installation. The NEC addresses the use of conduit in underground installations. Underground installations are subject to unique environmental conditions such as moisture, corrosion, and physical damage from soil movement. The NEC specifies the types of conduit that are permitted for use in underground installations, and it provides requirements for their installation. These requirements are designed to protect the conduit and conductors from these environmental hazards. The NEC provides guidance and the proper methods for sealing conduit systems. Sealing conduit systems is necessary in some applications to prevent the ingress of water, gas, or other contaminants. The NEC specifies the types of sealing compounds and devices that are permitted for use with different types of conduit, and it provides requirements for their installation. The NEC also addresses the use of conduit in high-voltage installations. High-voltage installations require special precautions to protect workers and equipment from electrical hazards. The NEC specifies the types of conduit that are permitted for use in high-voltage installations, and it provides requirements for their installation. These requirements are designed to minimize the risk of electrical shock and other hazards. The NEC provides guidance and the proper methods for inspecting and testing conduit systems. Regular inspection and testing of conduit systems are essential for ensuring their continued safety and reliability. The NEC specifies the types of tests that should be performed on conduit systems, and it provides guidelines on the frequency of these tests. In summary, while the NEC does not mandate conduit use universally, it provides extensive guidelines and requirements that often necessitate its use in specific situations. These situations typically involve concerns related to physical damage, corrosive environments, wet locations, exposure to traffic, and the need for grounding and bonding. Understanding these guidelines is crucial for ensuring safe and compliant electrical installations. The NEC also provides specific requirements for different types of conduit, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid non-metallic conduit. Each type of conduit has its own advantages and disadvantages, and the choice of conduit will depend on the specific requirements of the installation. Compliance with the NEC and local electrical codes is essential for ensuring the safety and reliability of electrical systems.